after a certain amount of time.
Wait, what? Mafia, but with math. There we go. There we go. Oh. Yes, like that.
All right, shall we get started here?
No. Do I get to use the laser pointer again?
No, that turned into a big mess. I shouldn't even try that.
No, it wasn't a big.
What was I thinking?
Oh, we can do it this time. We can do it.
Yeah, you're lucky we all walked out of here able to see.
I won't point it in anybody's eye. Yeah, I didn't try.
You pointed it in McKinley's eyes. McKinley pointed it in my eye.
It was an accident. When I pointed it in your eyes, it was an accident.
Also, that was all you were doing.
I was still fun part. I was still doing math.
I was pointing like an infinitely long number.
And Ben wasn't there. We couldn't point it in his eyes either. I missed all the fun.
Funner is.
Aha, I'm so lucky.
You just point at the screen. Yeah.
All right, any questions on review number 1? Now it's chapter
I
1
went
and
over
2.
to Ben's house and shone in his eyes. Can I use it?
No.
Would it take you like?
I mean, you live, unless you want to take 20 minutes walking down the side of my road and going to every house, knocking the door to see which one I live in, give you a shot. Oh, yeah, that's right. Dang it.
Foiled again.
He knows where I live.
Darn you meddling kids and your mangy dog.
Yeah. You're a mangy alien dog.
All right. Here we go. Madison, are you here or is it just Ben?
Madison is here. She's connecting to audio.
Cool. All right. We have a quorum. All right. So we'll do this not too quickly, but quickly enough. Remember, the purpose of this is just take a break about a month and a half to go before semester finals, so we don't. The nice thing about geometry is, for the most part, it builds upon itself and it uses all those skills. But there's a few skills that we don't see, and you get to see them once or twice, and then they'll be on the semester finals. So this isn't necessarily just those skills, it's pretty much everything. But these are the most important critical skills from chapters 3 and 4. So chapter 3 and 4 starts off with this construction right here, or more appropriately, when H and K are parallel. But this was how it started off, and we got these 8 angles. The 8 angles are created when 2 or more lines are cut by transversal. So go ahead, McKinley. Tell me one set of angles that we get. Names.
Interior angle.
Oh, that would be angle.
1 and 6.
That would not be 1 and 6.
1 and 8.
That would not be 1 and 8.
3 and 6. 4 and 5.
Okay. Alternate interior, Jack. We also have.
Not corresponding.
Which would be.
Like 1 and 5, 2 and 6, 4 and 8, 3 and 7.
Allie, we'd also have.
Same side interior, which is 4 and 6.
And we haven't talked about it for much. We also have.
Same side extra.
We never talked about that, but we do have that. And we could prove that. We never did. But we did prove alternate exterior. But we do have same side exterior as well, too. So all of those. So we got alternate interiors, we just mentioned. Just remember, we get the one theorem. Now, remember, this is, if they're not parallel, we get alternate interior, but we don't get that they're congruent. It's only when H and K are parallel. But if they are parallel, then alternate interior angles are congruent. How did we prove that? Well, let's think back. So I believe we start off that they are parallel. And I believe that we get the corresponding angles are, that's the postulate.
Yeah.
And I forget which postulate number that is, but basically, because K would be parallel to H, if you slide it down, you're not changing its orientation. Therefore, it's easy to see that angle 1 would be congruent to angle 5. Once that's done, then we have the corresponding angles congruent. So we say that 1 is congruent to 5, and then either linear pairs or whatnot.
Oh, okay, I can see it now. You can
And
see
then
that
vertical angles.
Nice. Yeah, 4 is congruent to 8, 5 is congruent to 8. Substitution.
Correct. Okay. All right. So we got alternate interior angles are congruent. You mentioned same side interior angles, but when they're parallel, they're not congruent. We get that they're supplementary. Who's on that darn person scam? He likes calling me.
Why is your light flash?
Because I'm a teacher, and typically what happens is I forget that I put it on silent. So when I get home, I put my phone like that, and then all of a sudden people are calling me, and I'm like, I don't know that they're calling me, so you turn the
We should answer scam and figure out what he wants.
I've been tempted to, but then I'm just worried that then they'll know that the phone number is real, and you know.
My brother always answers scam calls, and then he starts annoying them, so they just hang up.
How does he? What kind of scam?
All right, back up here. All right, so same side interior angles are supplementary, so 4 plus 6, or measure angle 4 plus measure angle 6, 180, and same thing with 3 and 5. Okay, you also mentioned corresponding angles. What's the deal about them? I've already said it. They're congruent. And remember, once again, it does not, they are still called corresponding when it looks like this, but they are congruent when H and K are parallel. All right, so they're going to make it more challenging. Obviously, they're going to put some, variable expressions in for it. So McKinley, first one, how are we going to figure out what those angles are?
They're equal to each other, so that 1 equals -5. That's not right. Anyway.
How about you start from the start? And
23x equals 24x plus -5. Then you subtract 23
from both sides. And 23x more precisely.
Yeah, then 5 equals x.
Okay. Therefore, how big is the angle?
5. No, you have to put it back into the equation. 24. It gets you a big number. Then you subtract it.
Okay. Very well said. So that's 120. Is that right?
Yeah.
120 minus 5, 115. Okay. Jack?
Yep. 11x plus 2 plus 11x plus 2 equals 180.
Okay, let's start smarty. Stop on there, smarty pants. All of you are smarty pants. Ben, look at that side.
What is that?
So the question is on the second one there. Don't say anything.
Okay, I'm looking.
Do we actually need to do any algebra there, or could you make a statement? By the way, period 1 or period 2 figure this out too. Look at the second example there.
I'm looking at the second example.
We could do some algebra there.
Well, I mean, you don't need to.
Why not?
Because they're the same equation. No,
Well,
not equation. They're the same expression.
Therefore,
no matter what, even if you change the value of even though x, it can be no matter what x is, they will always equal each other.
how big is the angle?
90 degrees.
Okay. So did you guys all get to that conclusion before he did? Okay,
Yeah.
yeah.
After the conclusion, as soon as we told Ben to say something.
But by the way, that's the
Well, thank
only
you.
one.
I'm glad I could help you.
Okay, so yes, I mean, but you know, if you really do the math, you still get that. You plug 8 into x, you still get 88 plus 2 is 90. But if you're on the ball, period 2 was as well too. You can get that answer before that. That only happens one special time. All right. What we haven't talked about in a long time, and that we will eventually see again, is the converse to all of these statements. The converse says this, that if alternate interior, or if same side interior are corresponding or supplementary, or if whichever the last one I left off, complementary or corresponding angles are congruent. If that is the case, then you have parallel lines. So we actually get 5, I believe it's 5 of these. So to show that 2 lines are parallel, you just show that any 2 corresponding angles are congruent. Any 2. You don't have to show that all 4 pairs. Show that any alternate interior angle is congruent. Show that any same side interior angles are supplementary. But we also get some more. These are more infrequently done. It's got to be in a plane. But if you show that 1 is perpendicular to 2, then, well, what you're really doing is you're showing that same side interior angles are supplementary. Or maybe you're showing that corresponding, right? That's one way. And we had a theorem about that. Alternate exterior, we did that one time. And then I lied, there's 6 of them. Show, and this was the weird one, it's that transitive one. If one line is parallel to a second, and a third line is parallel to the second, then the first 2, or the first and the last, are parallel to each other. Very infrequently used. Okay, so when you're presented some of this, it looks like what we did before, which is if this is 76, how big is this? But what you're really showing is, in order for you to be parallel to V, Madison, the question mark would have to be the one on the left. Can you hear me, Madison?
63. What?
Nope.
76. There you go.
All right, 76. So as long as question mark is 76. And Allie, on the second one,
Where are you skipping me so much?
what?
67.
67. Okay. Cool. All right. Anna, remember triangles? Give me all of them by side lengths.
Like isosceles,
There's one.
right?
No. Right is an angle, not a
Oh.
side.
Obtuse.
That's an angle again. You're 1 for 3 right now. You start off with isosceles. What's an isosceles triangle?
Where the base angles are congruent.
Okay,
and
that's a
the
theorem that we got from it. But by definition, isosceles triangle has nothing to do with angles. It says
sides of it.
how many? Two sides. The theorem, we'll talk about that here in a little bit. The theorem says that if you have an isosceles, then the base angles are congruent. Okay, so there's 1 of 3. What are the other 2? No sides, 2 sides, no sides, 2 sides, 3 sides. You just gave me 2 sides. What are the other 2?
So where none of the
Sides are the same. Called a. Boy, good thing we're doing this review. We didn't commit that one to memory. How about 3 sides?
Commit nothing.
congruent.
Good thing we're doing this review, McKinley. You got either one of those 2? She got like 2 sides. What are no sides or 3 sides? No sides congruent.
Oh, no side congruent. Yes, that's an no side congruent.
That's right, but we got a name for it. Really?
I know.
Go ahead, Ben.
Scalene.
What about all 3 sides?
The scalene triangle is a triangle that's not congruent. Has no
What about
congruent.
all 3 sides?
All 3 sides,
Yeah.
Being congruent.
they're all different lengths.
We got it? It is a regular triangle. It is. But we have another name for it. And I probably would have counted that if you put regular just for coming up with that idea. Go ahead.
Equilateral.
Wow, that's like pulling teeth. That was bad. You guys are supposed to be the advanced class. You really don't remember that?
Skipping me. Well, I have it in my notebook because I don't remember
Yeah,
stuff
but-
like this.
By the way, this was 7th grade. We did this in 8th grade, and now we're doing it in 9th grade. You had 3 years of those 3 triangles. Are we going to do any better if we do this by angle measurements?
Yeah.
McKinley? Angle measurements.
There's the right one.
Okay, that's 1 of 4.
There's the isosceles one.
That's by sides.
The complementary one.
No complementary
Not
triangles.
complementary, I mean supplementary.
There's no supplementary triangles.
Yes, there is. There's a supplementary.
Supplementary angles. So we got right triangle.
Technically, all triangles are supplementary.
Technically all triangles, but we usually say supplementary or complementary only for 2 angles.
I know, but
I got you. I got you.
there's the cone-shaped one.
What?
The cone-shaped one.
That is a sector of a circle,
That is
which we will be covering in 5 chapters from now, 4 chapters from now.
whatever Jack has to say. That will.
Madison, can you give us any help classifying
Madison
triangles?
left. Madison's
Okay.
gone.
All right.
I can give you some help.
Got this? Equilingular? Equiangular, okay. 2 left. We got right and equiangular. There's 2 more. And she said 1 of them.
I want to say so.
Clearly, next year for my kids, I'm going to have to hammer this a little bit harder. What do you got?
Acute and obtuse.
Right?
Oh yeah, acute and obtuse. Those things exist.
All right. By the way, equiangular are also,
Equilateral.
okay, any one of these can be also,
Equilateral.
no, not true. It is true for the acute, though.
It is, and it's also true for the right.
It's
No,
not true for the right.
and it's not true for the obtuse.
Right.
Any one of them can be triangle.
Any one of these could be isosceles,
Oh,
right? The acute can be equilateral as well too. The obtuse can be isosceles, and you can't get a right obtuse. And obviously a right could be right, or it could be isosceles, and it can be only acute. Right? Well, it's not called an acute triangle; it's called right triangle. But the two angles are acute. You can never get an obtuse angle at right triangle. You can only have one obtuse angle in an obtuse triangle as well too. Wow, pretty bad. All right.
You haven't even.
Well, when only 1 out of 6 people gives me the answer, that's bad.
Well, one's gone right now. So technically it's out of 5. So it's
Well,
not a
1 out of 5 is 20%.
Madison. He's not here right
Right, but 1 out of 5 is 20%.
now. That's not that bad.
I give you a 20 out of 100 on a test, you're happy?
No. Yes.
All right.
If it's a 30 and a 20.
Now, I never said anyone had to memorize these numbers, but from the picture, McKinley, try to guess what I'm about to say.
That 1 and 3 equal each other.
Only if that's how
Only if it's an isosceles
But it clearly is.
or equilateral.
It clearly is an isosceles.
It does look that way, doesn't it? Okay. All right, can you tell me anything else? I'll accept that. It does look that way. Oh, by the way, we couldn't accept that in geometry, is true.
1 and 2 equal 180. That's a thing.
1 plus
So
2 equals 180?
Yes.
1 plus 2 equals 180.
The measurement, angle 1 and 2 equal 180. Or measurement 1 or 2.
Okay, so you just made a triangle where the first angle plus the second angle equals 180. So let's see, what's the smallest that could be? That means one of them is 90 and the other one is 90. So you just made a triangle, right?
Yeah.
There's your triangle. Your triangle looks to me more like a quadrilateral.
In spherical geometry.
Right? In
That means
spherical
that's a-
geometry, yes, that's true, but we're not there.
3
and 1 are definitely equal together. 2, what does B?
How about just any triangle in general?
They all, it's a triangle.
Okay.
And,
I don't think we had a theorem that said if you have 3 angles, it's a triangle. We have a definition, by the way.
well, there is a thing I must research real fast.
All right, Anna, what am I trying to say here? Take a guess.
Yes, I'm not the worst.
Oh, no. I don't expect anyone to remember 311, but you could tell me something about the shape I just drew. Well, that's a guess. If this was 311, you would think that there'd be some markings on it if it was something to do with isosceles. And there's no markings there, but there are 1, 2, and 3 labeled.
I was right. I'm so right.
2,
I am close though.
1 what? 180. So that's 311. You don't have to remember 311, but you do need to remember that the sum of the interior angles of a triangle are equal to 180. Now, we actually had this 2 different theorems that said the same thing. What was the other theorem that said this?
Theorem 6.
And it's a little bit of a stretch. What was the other theorem that said exactly the same
It
thing?
was like corollary 1.
No. I'm reaching into next chapter, chapter 4.
Was it the one that's like the
Oh, congruent triangles.
No.
amount of side?
Notice this is exactly the same as
Money.
n minus 2 times 180.
Oh, right.
Right?
Okay.
I was close to right.
And by the way, we proved that theorem when in fact all we had to do was say, for at least for the triangle, it would have been true for the triangle. We had to prove it because it was talking about polygons in more general form. But certainly a triangle is polygon. Okay, so that's 311. That's pretty easy.
No.
Let's try this one more time. McKinley, take a look at the picture and try to remember. Don't look in your book of truth. What was 312 all about? Here's the picture.
All right. So clearly 4 is an add-on. So A through B, A and B, A is and B are part of the array. That's something.
Okay, true.
4 is equal to 1. That's true.
Well, 4 could be equal
No, it is because it is
to not 1, but 4 could be equal to
2, 3.
that's never going to make a triangle.
It will.
Not if 4 is equal to 1 or 4 is equal to 2.
Well, I was saying
4
4
is
is equal to 3. That's what I was saying.
Didn't say that.
That's what
Wait,
I
4
said.
and 3 together equal 180. That's something.
That is true. But
Yeah.
I did write the numbers red.
And then what is 3 plus 2 plus 1?
Oh, 4 is an add-on to make it.
What do you mean an add-on?
That's not what a triangle is supposed to look like.
Agreed.
You could, it's the start of construction, another triangle.
I did. There was a construction there. We would call angle 4. Okay, what do you know about that then?
They're outside.
Okay, true.
They're bigger.
I'm getting the impression I should have done this review a long time ago. This was chapter 3, by the way. That was 2 chapters ago. And you've already forgotten this. Why are 1, 2, and 4 red?
Because they are red. That's
All right, you really remember it? The
I
rest of you?
remember it.
All right, Jack, what do you remember?
Angle 4 is equal.
La 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 la.
You asked me what I remember.
I know, but all I'd ask you to do is raise your hand, so therefore I'm going to take you at your word. But I don't know if Jack. Jack, do you remember?
Yeah, I do.
Ben, why am I doing it again? Ben, do you remember?
Remember? No.
This picture.
Oh yeah, I do remember that.
What is it?
1 plus the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4.
You have a triangle, and you create an exterior angle. It's equal to.
The 2 opposite angles.
We're not going to use base,
Opposite.
and we had another word for it.
Um,
Yeah, start with the letter R.
oh.
It was equal to the remote.
Remote. Okay.
The 2 remote. Now remember, the remote aren't the base, right? They're just the angles, like you said, that were opposite's kind of a hard word to use, but that's the general idea.
I was close.
No, you were pretty far off, although the one thing you said about 3 plus 4 was the only thing that was good.
So then that way you can prove it by 3 plus 4 equals 180, 1 plus 2 plus 3 equals 180, and then you subtract 3 from both ways.
You do a substitution, right? And that's how we proved it, by the way. Okay.
I got this one.
Oh, you do, McKinley? So what's the answer?
180 minus 107.
What?
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 What? What?
What was the zero?
What?
What was the zero?
Well, yeah, the exterior is equal to those, so it's 80. So it's 107 minus 84.
Oh, there you go.
Ah, I figured it out. You guys did.
Okay, so that's a little bit better. All right, so 107 minus 84, so 23 degrees. All right, notice we were solving for one of the remote angles. We could also solve for one of the exterior angles. Go ahead. What do we do? All right, well, that one's not too challenging, right? Okay, cool. You guys, by the way, had forgotten this until I had to remind you.
Oh, no, I did not.
Well, I'm going to say you guys, and 75% of you. No, sorry,
Was it-
80%.
What about me? I was the one who said it.
You were the one that said it. Jack was trying to. All right, one more time around the room. Smallest polygon, number, sides, and its name. Name.
What? Oh, pentalateral or something like that? 5 sides?
I'm gonna throw things at you now.
Quintilateral. Or
What?
pentalateral.
Pentalateral.
I can't remember.
Latin word.
You seriously don't remember? Or you pulled my leg.
Wait, what is this?
McKinley, help him out.
A pentagon.
Oh, pentagon.
Pentagon. Pentagon.
You guys are making up words.
Parallel. No, that wouldn't be right.
Well, how many sides?
It's 6, so sixtagon.
Sexagon would make more sense.
Sixarella, yeah.
What's 6 in Greek?
X.
No, I got
I'm not 100% sure if it's Latin or Greek. I think it's Greek though.
It's Latin.
It didn't in Latin, it's not.
Wait.
I think it's
Not
Greek.
Latin, because 6 in Latin is 6. No, it's not.
Yeah, you're.
You get it. All right, we're back.
7 septical.
Okay. Septagon is an acceptable one. Our book uses heptagon.
Octagon.
9 is nonagon.
I think I've heard that
Pentagon.
one, but not pentagon. I've never seen
And Entagon. Engon.
An n-gon, right? We could say decagon, but
Why did you say n-gon for any of these?
n-gon for any of them, right? So, but we reserve it for when we say there's n sides. We're thinking of an imaginary polygon that has n sides. We don't
I
know.
can draw a 20-sided polygon.
20 side. I'm not sure how you say 20. I stop at dodecagon is
But
12 sided.
I
So
can
you would
draw
say
a
a spaghetti
20
on,
side.
I don't know.
I can show you how to draw a 20 side.
How come all of them are gone except for triangle?
Yeah,
and
shouldn't it be
Right.
trigon and
quadrilateral?
quadrilateral?
I'm with you on that, right?
Or the rest of them should be ended.
Hey Siri, how do you? What's the name of a 20-sided polygon?
Also, triangle really doesn't make sense for the number side.
I cost.
Isn't it a dodecahedron? Or is that
No,
12?
that's three dimensions. Hedron means 3 dimensions.
What's
Oh, yeah.
million?
All right.
Milligon? Yeah.
Okay. Let's see this. We got formulas
They're all
for calculating interior angles and exterior angles.
they're
Remember,
all parallelogram.
do you
especially the triangle.
remember
I
those
remember that.
formulas?
They're all parallelogram.
All right. First one, go.
All right, the sum of the interior angles is n minus 2 times 180.
Okay. Go ahead.
N minus 2 times 180.
Now we're doing the exterior angles.
360.
How do you remember that? And you can't remember
Oh.
isosceles.
Because I remember the big stuff.
N over 36.
And I'll just say, this is what I did. If you're going to measure the exterior angles, when you measure this one, cancel that over here, and then it goes to here. Bring that down to here, it goes to here. Bring that over here, it goes to here. Bring that up to here, and it gets back to where it started from. How many times did I flip this around?
It's a circle.
One time, so 360 degrees.
So you just make a circle out of all of the exterior angles of the polygon?
Yeah, for exterior, not for interior, but for exterior. Right?
Oh, that makes sense.
How do you find one of these?
N minus 2 times 180 divided by 360.
No,
No, n minus 2 divided by 180.
no.
Yes. No.
What do you
I
got?
don't know.
N minus 2 times 180 divided by 2 for n.
But divided by n, because
I was close.
you were close.
Very close.
You were nowhere
All right,
near.
McKinley, prove yourself to do the last one then.
N minus 2 over 36.
This, what does it say, interior or exterior?
Exterior. I said 3600.
What?
360.
Keep talking.
N minus 2 over 360.
So then what if you...
If all of the angles on the exterior of any polygon add up to 360, then how would you find one of them?
By putting the n somewhere and then dividing it by 360 after you subtract it by 2.
You flip it.
No.
The 360 minus 2 over n.
So
370.
how many sides on a rectangle?
Oh yeah, 4.
Okay, so 4 minus 2 is 2. 2 times 1, so there's 360 degrees on the interior. To find one of them, you divide it by how many sides they're on. Okay. Now go to exterior angle. It doesn't matter on the polygon. It's always 360. So how do you find out what one of them is?
N divided by 360.
You're saying it wrong.
Oh, 360 divided by n.
All right.
Yeah, I was right. I just said the words were
I know, which is why I said you said them wrong. All right. So really, it's just these two formulas, or it's these two, however you want to think about it. Knowing that to convert between the two is one is you're dividing by how many sides you are, one you're not. Okay. You will see these formulas pop up even in pre-calc calculus as well. All right, what's regular polygon? Since you brought it up the other day, or you? What's a regular polygon? You used the word, and I said, sure, I'll accept that for that answer. So why did I accept regular for that answer? What was the shape we were talking about?
Triangle.
What kind of triangle? And it was not isosceles.
It was I wanted to.
So why is an equilateral triangle a regular polygon? So if you have a polygon where and there's one other thing we gotta add to that. Then that's the definition of a regular one. So We got a regular, what is this? Quintilateral.
27.
So we got a regular
One thing
quintilateral.
wrong.
She's
I got
got
one thing wrong.
quintilateral.
So we got a regular pentagon. What is the sum of the interior angles, McKinley?
It's 180. Yeah, interior angles. They
What
all
was the
have
formula?
3 minus n.
What's the shape?
Oh yeah, the 3 minus 2.
Where are you getting a 3?
Because there's three sides.
On a pentagon.
Oh, that's 6. That's 5. Oh, 5 minus n times 180. No, divided by 360.
You're lucky I let you use a book of truth, McKinley. I'm not sure you'd make it through geometry without the book of truth. What was the formula?
It's the sum of the interior angle. But yeah, I'm right. It's 5 minus
What's the
2
formula?
times 180.
All right, 5 minus 2 times 180.
You kept on confusing.
I didn't do anything except ask you.
5 minus n times 180.
All right,
And then you said only 3 times.
so what are we going to do?
3
Times 180 is 540. Okay, so the interior angle is 540. Jack?
What? Oh, what is the sum of the exterior? Oh, really? You give me the easy one.
I don't know, but you also.
360.
Okay, so those are generally how the question is asked, but not always, because the question could also be asked an. In other words, 1. Ben, what's the answer to this one? You can just tell me what to do mathematically. You don't have to actually do the math.
What to do mathematically?
You don't have to tell me the number answer. You can just say, I would need to do this.
Oh, okay. Well, first I would need to take 540 and divide it by, what the heck? 540 and divide it by 5.
Okay, that's all I wanted to hear from you. Okay, so there we go. All right, next question. What's the value of and 1,
360 over
which in this case,
is over 5.
you can do that in your head, right?
It's 69.
Oh, you were so close.
What is it?
60, 12. 670.
I'm waiting for an answer.
It's 60.
60. Yes, it's just 60.
Don't listen to that.
No, it's not 60.
Do your own
It's
math.
not 60.
It's a 6, which you get 6, so 31
You can do this in your head.
points.
You're confusing me. I'm doing this in my head.
72.
Thank you.
Yeah.
All right.
I was close.
Chapter 4, very quickly, was all about triangles and proving that triangles are congruent. There are 5 ways to prove that we have so far. There are a couple more. Our book doesn't choose to show them all. But there are 5 ways to show that they're congruent. Just remember, hypotenuse leg only applies to right triangles. Okay? Isosceles triangles, we've already said it one time before. We've said it before. Isosceles triangles are a triangle that has 2 congruent sides. The angle between the 2 congruent sides is called the vertex. The 2 sides that are congruent are called the legs. And the opposite side of the vertex is called the base. Okay? The 2 angles that are attached to the base are called the base angles. And the so what about isosceles triangle is?
It's the basic.
The base angles are congruent. We also have the converse to that. If the base angles are congruent, then you have an isosceles triangle. You also might have an equilateral triangle, but you're guaranteed to at least have an isosceles triangle. All right. The line that goes from a vertex to the middle of the opposite side of a triangle is
It's the
called.
medium. I knew this one. It's the
Oh,
medium.
no, it's not.
No,
It's the medium.
Yes, I'm right. Woo!
Okay. McKinley, what do you call the line segment that goes from the vertex to the opposite side and it forms a 90-degree angle? What do we call that? This is probably a forgettable one.
The 90-degree angle.
How do you remember this and not scaling? That's crazy.
I remember.
We've
scaling.
used scaling. We've
I
never
remember
used
everything
this.
except for Pentagon.
What is it called? It is called an. And I realize it was a question on the test, and you missed it, most of you. But yes, that is called an altitude. All right, and that was it. All right, here's your homework. Tell us about the ring.
Can I
I
go
wonder if
home
we've
now?
done more research than daily
I count this as an absolute.
How did I forget Pentagon?
I don't know.
Single thing else.
Well, I showed you my fickling the kid made me last year, right?
Attention students. and
I've told you the
teachers,
fickling story, right?
At this time, please dismiss all fifth, 10th grade
I had a kid,
pipeliners,
this was probably about 8, 9, 10 years ago, on a geometry test, not in geometry, but in like pre-algebra or something. I said, what's a 5-sided polygon? And they put fickling. And to the life of me, I don't know where they got that from. So I always tell the story. And then last year, a kid who has a 3D printer at home made me a fickling.
That's an actual thing.
No, it's not. But he made me a pentagon and it has the word fickling on it. And I don't know where it is. But I had it right here. Stack 3 chairs.
Look how small this shirt is compared to
Where is my fickling? Who stole my fickling? Here it is. That's a small shirt. Where's my fickling? Look at my quadrilateral.
I'm gonna be thinking about that for the rest of my life. I treat people scary eyes.
All right. Then you guys have a good weekend. We will catch you on Monday.
Teachers, please start dismissing from the Carline app. At this time, please dismiss all first through fourth grade walkers,
Are you alive, Ben?
riders, and fun playgrounds.
Yes. Look for it.